Today we're going to learn how to create equations from graphs. If you recall, the equation of a line looks something like this. Y equals mx plus b. This is the slope-intercept form of an equation of a line. You should know what a graph looks like. It will typically look something like this. This is the x-axis, that is the y-axis, that is the origin, and there'll be some sort of line. Okay? There are two terms that we first have to review: positive correlation and negative correlation. They both describe the behavior of a linear relation. For positive correlation, one variable increases while the other also increases. For negative correlation, one variable increases while the other decreases. Let's demonstrate these two terms with a diagram. So for positive correlation, I'm going to draw myself a graph. So that is the x-axis, that is the y-axis, that is the origin. A linear relation with a positive correlation looks like that. You'll later learn that this line has a positive slope. Okay, so you'll see some words repeating: positive slope, positive correlation. As you can see, as the values of x increase, the values of y also increase. Therefore, it is a positive correlation. Negative correlation is very similar. I'm going to show you what that looks like. So again, I'm going to draw myself a graph. That's my x-axis, that's my y-axis, that's my origin, and I'm going to have a line. This line is going to look like that. And this line, you'll learn later, has a negative slope. Okay, so again, you'll see terms that are being repeated. As you can see, as the values of x increase, the values of y decrease, which makes it have a negative correlation. So let's just show you these two diagrams again. We're going to apply our knowledge now. If you remember, the minimum wage currently is $11.25. That is the general minimum wage. However, minimum wage is actually increasing to $11.40 as of October 1st, 2016. So in about a week. What I've done on the side is create something called a table of values. As you can see, this displays time in the left column and earnings on the right column. Time is the independent variable, while earnings is the dependent variable. A lot of students get confused between the independent and dependent variable. This is how you can remember. Earnings depend on time. The more you work, the more you earn. It is not the opposite, where time depends on earnings, because that doesn't make any sense. Based on this table of values, you can calculate both run and rise. So let's take a look at these values. I'm not going to do the calculation for all of them, but you can pretty much see that each of these values are increasing by 1 each time. So I'm going to say the run is equal to 1, so 1 hour. Over on the right side, you can see earnings. And what I want to do is figure out how much these earnings are increasing. And that would be considered the rise. If you look carefully, the rise is always the same amount, and that amount is $11.40, because for every hour you work, you earn another $11.40. There's one more value you can extract, and that is something called the initial value. Therefore, you can extract many pieces of information from your table of values. You can extract your run, your rise, as well as your initial value. If you don't have a table of values, you can look directly at the graph. In our graph, the independent variable is always located on the x-axis. So let's write that down again. Independent variable. Over here on the side, we have earnings. Earnings is located on the y-axis. The dependent variable is always located on the y-axis. So I'm going to label that dependent variable. And over here, you have what we call the initial value. And it is pretty obvious that the initial value is 0. We can find both the rise and run by looking at any 2 points on the line. Let's take a very close look at these 2 points. What you can do is create a little triangle like so. Over here, this would be considered the rise, and here, that would be considered the run. When you're looking at the rise, you want to see what the distance is between these 2 points. You already know that from the table of values, the rise is $11.40. And the same thing goes for the run. You want to take a look at these 2 points and see how much is between them, and we have 1 hour. So 1 hour has passed. So the run is 1. Just like our table of values, we've discovered many important pieces of information from our graph. We've discovered our initial value, our rise, as well as our run. We've also identified our dependent variable and our independent variable. Now that you've calculated both the rise and run, you can use those values to figure out something very important. And that important thing is the rate of change. Rate of change is equal to rise over run. We know what the rise is. We calculated that to be 1140. We also know what the run is. The run is 1. 1140 divided by 1 is equal to 1140. In this case, you can actually simplify the rate of change. In other cases, you may be better off just leaving it as a fraction. Based on the shape of our previous graph, we can conclude that a positive correlation is present, since earnings increase as time increases. In our previous lessons, you learned that the equation of a line in slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. These terms are pretty complicated, but there is another way of describing this. Instead of saying y, we can say dependent variable. Remember, the dependent variable is located on the y-axis. Instead of saying slope, we can say rate of change. Okay? And instead of saying x, we can say independent variable, since the independent variable is located on the x-axis. And last but not least, the y-intercept is considered the initial value. And I'm just going to show you where all of these things are coming from. In our previous slide, we calculated all of these values. We know what the dependent variable is. We know what the rate of change is. we know what the independent variable is, and we know what the initial value is. So let's go ahead and put those values in. The dependent variable was earnings. The rate of change is equal to rise over run. Recalculated that to be 1140. The independent variable was time in hours, while the initial value was 0. With that, we can go ahead and simplify this. Instead of saying earnings, let's just simplify that to a single letter. Let's just call that E. All right? And 1140 stays the same. This multiplication sign isn't really necessary, okay? And instead of writing time, you can just use the variable of t. So I'm going to use t, and I'm going to put it right beside 1140. Remember, when there's a number and variable beside each other without a sign, or operation I should say, the operation is multiplication, okay? And this 0, I am not going to bother myself with writing it in, okay? Therefore, your earnings at minimum wage can be described with this equation. E equals 1140 T. You might be asking yourself, what's the point of creating an equation? Well, this equation can help you figure out how much you earn at different amounts of time. Say, for example, you ask yourself this question. How much will I make in a week? In a working week, there are typically 40 hours. However, it gets a little complicated when you start factoring in breaks and lunchtime, but I'm just going to stick with 40 hours. Using our equation, E equals 1140T, we can figure out how much we will make after working 40 hours. Just like our previous lessons, what we want to do is we want to substitute in our known values. So I'm going to say sub t equals 40. I'm going to rewrite the equation exactly the same, except with 40 written in brackets. Now, you should know by now that there's actually a multiplication sign in between 1140 and 40. You can go ahead and use a calculator to calculate that. So 1140 times 40 is equal to 456. So I'm going to write E is equal to 456. Okay? And you can always write a concluding statement. I'm going to do that to set a good example for you guys. So I will make $456 after working 40 hours at minimum wage.